Hello everyone, this is Tim from Premium Tutor. Today we're exploring one of the neatest ideas in kinematics, which is projectile motion. It's what you get whenever you throw or launch something and then let gravity take over. No rockets, no engines, just a constant pull of gravity. So every projectile's journey is shaped by two factors: how fast it starts and how strongly it is pulled back down. In the vertical direction, gravity's job is quite simple. It slows it down on the way up, stop it for a split second at the top, and then speed it up on the way back down. So in today's video, we're looking at the simplest case, where there is no horizontal movement at all and just straight up and straight down. That means we can focus entirely on the vertical equations of motion. So here's the question. A ball is fired vertically upward from the surface of another planet. We're given a height versus time graph where y is the height above the launch point and t being equal to 0 is the moment of launch. The vertical scale is set so that y sub s is 30 meters, and from the graph we can see that the ball's peak height is 25 meters and the total flight time is roughly 5 seconds. So in this question there are two things we need to find. The first one is the magnitude of the planet's free fall acceleration, and the second is the ball's initial velocity. Alright, so first we need to understand the symmetry here. Because the motion is vertical and gravity is constant, we see that the graph is symmetric, which means the ball spends exactly as much time going up as it does coming down. So if the total flight time is 5 seconds, the time to reach the top is only half of that, which would be t top equals 5 seconds divided by 2, so it's 2.5 seconds. And then we'll use the vertical displacement equation from kinematics, which is y of t equals y0 plus v0t minus 1 over 2 gt squared, where y0 is equal to 0 since we start from the launch point, and v0 is the launch speed and g is the magnitude of the planet's freefall acceleration. The reason why there is a negative 1 over 2 is because the gravitational pull is in a downward direction. So after we simplify it, it becomes v0t minus 1 over 2 gt squared. We also have the vertical velocity equation, which is v of t equals v0 minus gt. And note that at the top, the ball's vertical velocity is equal to 0. So it simplifies to 0 equals v0 minus g times t top. So v0 is just equal to g times t top, which is an expression of v0, something we need to look for in terms of g, another thing that we need to look for. So now we can substitute the numbers into the results that we have obtained so far. So 25, which is the height of the peak of the trajectory, is equal to gt top times t top minus 1 over 2 gt top squared. And since the first term simplifies to gt top squared and it is subtracted by 1 over 2 gt top squared, it simplifies to 1 over 2 gt top squared. So 25 is equal to 1 over 2 gt top squared, which means we can simplify it to obtain an expression for g, which is 50 divided by t top squared. And don't forget that t top is 2.5 seconds, so it is equal to 50 divided by 6.25, and that will be equal to 8.0 meter per second in a downward direction. Alright, so far we have obtained the value of g, the gravitational acceleration of this particular planet. The next thing to do is to find the initial velocity of the ball. Since we already have an expression for the initial velocity, which is v0 equals g times t top, we simply have to substitute the numbers in, which is 8.0 times 2.5 seconds. So that would be 20 meters per second in the upward direction. So on this planet, we know that the free fall acceleration is 8.0 meter per second downward, and the launch speed of the ball is 20 meters per second upward. So that would conclude this entire question. This is an interesting example of how much you can get just from a graph and the kinematics equations alone. So if you have any question, feel free to contact us. You can message us, you can add us online or on messengers, or just leave a comment to express what your questions are. And thank you very much for watching this video, and don't forget to subscribe for more content like this, and I'll see you next time.